Yeah, so geometric progression, this is under series and sequences. So when you're talking about a geometric progression, it is a series which only differ where the elements or the values differ by a common ratio. For example, if the first term is going to be 2, the next one is 4, the next one is going to be you can determine the rest. Okay, you can determine the rest here. Now, how do you get to determine that? The formula is, of course, before you even use the formula, what you are going to first determine is the common ratio. If this was an arithmetic progression, we determine the common difference. But this is a geometric progression, so we're going to determine the common ratio. And the common ratio, which is R, is given by second term divided by the first term. Okay, that's how you determine. Are we good with that? So from here, the second term in this case, the second term, as you are able to see, is a 4, and then the first term is a 2. Okay, yeah, so that means that for this one the common ratio is going to be a 2, like that. Okay, now if we've seen that this is going to give us a 2, how are we able to find now the other terms which are in front? So if you see, this is a common ratio and the first term we had is a 2. How did we get a 4? You always multiply by the common ratio. Okay, you always multiply by the common ratio. For example, uh, yeah, as you are able to see the second term here, the second term is 4. That is because we did 2 times 2, the same common ratio. So if we want to find the next term, we can now list this series. Let's try to list all the elements. Let's say up to the seventh term. So we're going to say 4 times 2, that is going to give us 8. 8 times 2 giving us is a 16. Okay, the next term will be 16. 16 times 32, I mean times 2, that will be 32. 32 times 2, 64. 64 times 2, that will be 128. We'll continue going like that. So you always multiply by the common what? By uh, the common ratio. That is how you get to find the the next term if you know the first term. Are we good with that? All right. So now imagine they gave us the first term and the second term, and then the question just said find the fifth term. Okay, find the fifth term. So if we want to find the fifth term in this case, of course, multiplying by the common ratio, you can say this is first term, second term, third term, fourth term, fifth term. We've seen that the fifth term is supposed to be 32, but there is a formula that we are able to use for us to be able to get that. And for an arithmetic, a geometric progression, any term is given by ar to the power n minus 1, like that. Okay, so in this case we're talking about fifth term. Fifth term is going to be equal to first term. You can see first term is a 2, open brackets, r is the ratio. In this case the ratio is 2 also, and then to the power n, we are talking about what? Fifth term. Okay, so that is going to be 5 minus 1. So this is going to give us 2, and then 2 to the power 5 minus 1, that will be 4. Now 2 to the power 4 means 2 times 2 times 2 times 2. 2 times 2, this is a 4. Okay, and then 2 times 2, that is also a 4. 4 times 4, this is 16. So this is going to be 2 times 16. And we know that 2 times 16 is a 32. We can even confirm this is the value which is here. So when you are finding the next term or the nth term in a geometric progression, you need to know this formula by heart. Nth term is ar to the power n minus 1. That is how you get to find the nth term of an arithmetic, I mean a geometric progression. Are we good with that? Alright, let's put down another question. Let's say the first term that we have, let's say the first term is so we have got, let's say, 2, 1. Let's also have a half, and then it goes like that. Okay, and then we have got now questions. Question 1, given this is a GP, and then question 1 they say find the formula of the nth term. And then part B, we also want to find the fourth term. Let's say let's find the fourth term. Let's find the fifth term. The previous one we found the fifth. Let's find the sixth term here. Okay, find the sixth term. So how are we able to work out this one? The first thing first, remember, when you want to find the formula of the nth term, first write the formula itself, the general formula. Nth term is given by ar to the power n minus 1. Okay, so this is the formula of the nth term that we are going to find. So the first thing again that you need to find is the ratio second term over first term. So in this case, this is the first term, this is the second term, this is the third term. So second term is 1, the first term is a 2. So this is the geometric ratio. So where there is a, we are going to substitute that first term. Our first term is a 2. And then where there is r, we are going to put our ratio there, which is a 1 over 2. And then we're going to write the power n minus 1. Now we want only the formula of the nth term. Okay, only the formula. Now we know indices, so this is going to be 2. When you are talking about indices, you have got a over b, and then you have got power n. This is the same as a power n over b power n. Okay, like that. This is from indices. So 1 over 2 to the power n minus 1 will mean we are going to get 1, and then we set to the power n minus 1. We're also going to get in the denominator 2, and then we also set to the power n minus 1. Never multiply 2 by what is inside. Please never do that. Why? Because this one has got a difference power with this one, so you can't multiply those. Never multiply this. Hope that is okay. Now you also know that 1 to the power x is always equal to 1. 1 to the power anything, it doesn't matter what x is, as long as the base is 1, it will always give you a 1. So this will give us any term being equal to 2, open bracket. So 1 to the power n minus 1 is still a 1 over 2 to the power n minus 1, like that. Okay, now reaching at this point, since this is now just a 1, it doesn't have any power, I can now multiply. So we're going to have any term is 2 times 1. Okay, you've seen I couldn't multiply with this one. Why? Because the one had a different power. But now since 1 doesn't have anything, I can now multiply. So 2 times 1, that would be a 2 over 2 to the power n minus 1. Again, from indices, when you have got any number to the power n over that same number to the power m, same bases dividing, subtract the powers. So you subtract the powers. Even here we have got same bases, we are going to subtract the powers. So it's going to be 2. Of course, if you have the 2, this means it is 2 to the power 1. Okay, so we're going to say 2, this power 1 is the one we are going to get first, 1. And then minus, you come now to in the denominator, you get the power. Always put the brackets I've put there, n minus 1. Always put these brackets, because if you don't put those, it will change the meaning of the equation. And this will give us 2 to the power 1. And then I'll distribute negative times n, negative n. negative times negative 1, positive 1. And this will give us now 2. So we can add 1 plus 1, that is going to give us a 2. And then we've remained with a n. So therefore, for this question, the formula of the nth term is going to be given by 2 to the power 2 minus n. This is the formula of the nth term. Is this fine? Do you have a question? Alright. Now we can find question B, which is saying the sixth term. We know the formula of the nth term, so how can we find the sixth term? So we have said formula of the nth term is equal to 2 to the power 2 minus n. So we are going to say T6. This is going to be equal to, since we want a sixth term, going to be 2 to the power 2 minus, where there is n we put 6. So this is going to give us sixth term being equal to 2. 2 minus 6, that would be negative 4. And then from indices again, if you have got a to the power negative n, it can also be written as 1 over the same a, but the n becomes positive, like that. So even this one, we can write it as 1 over 2 to the power 4, but the 4 has become positive. So this will give us a sixth term being 1 over 2 to the power 4, means 2 times 2 times 2 times 2, which is what? A 16. So this is the nth term. If we didn't know, if we were not asked to find this formula, and then we were just asked to find the 16th term, we can just go direct. We know the formula of the nth term for a GP, that is a r to the power n minus 1. So say sixth term is equal to first term. We can see the first term is a 2. And then r, we determined r as half. And then n, we know that is 6 minus 1. So this will give us sixth term being equal to 2, 1 over 2 to the power 5. And here again from indices, we can say this is 2, 1 to the power 5, that is just 1. And then we are going to have also 2 to the power 5, like that. And 2 to the power 5 is, this is not 25, this is 2 to the power 5. Let me write it properly. Okay, we know that 2 to the power 5 is a 32. So this is going to be 2, 1 over 32. Now 2 can cancel here, and then 2 can go here 16 times. That will still give us 1 over 16. So we could have also said this. That is how we are able to determine the formula of the nth term, and also finding the nth term itself. In this case, we found the sixth term. Any question here? Any question? Okay, so I'm guessing this is okay, there is no question. Please, if there is any question, make sure that you ask so that you understand, because these things are very, very important when it comes to the exam. Okay. Okay, just a moment. So apart from us understanding the nth term, we should also be able to understand the geometric mean. This is one thing which is also very important, the geometric mean. Now, how do you find the geometric mean? Geometric mean, if you have got three terms, A, B, and C, we know that any term is given by what? Okay, we are not even interested in the nth term, but in the ratio. We know that a common ratio is equal to second term over first term. It can also be third term over second term, as long as you are talking of something in front over the one which is behind, like that. So in this case, we're going to say, what is our second term? Our second term we are able to see is b over our first term, which is a, and that will be equal to the third term. What is our third term in this one? Is a c over second term is a b. So cross multiply these. That will give us b times b, which is b squared, and that will be equal to a times c, which is ac. So to remain with b, we are going to square root both sides. That will give us square root of ac. This is the formula for the geometric mean. So if you are given two terms, let's say you have got 25 and 36, they say find the geometric mean. Find the geometric mean. To find that, we are just going to say b is equal to square root of ac. So get the first one, which is 25, and then multiply by the second one, which is 36. So this will give us square root of, we can even separate these. We'll say square root of 25 and then times square root of 36, since both are in the square root. We know square root of 25 is a 5, square root of 36 is a 6. 5 times 6, that is a 30. So this is how we're able to determine the geometric mean. So the geometric mean is a number that is between these two terms in a geometric progression or geometric sequence.